So as we get into this chapter 3 here with solving linear equations, a huge part of algebra and other mathematical disciplines, geometry, trigonometry, calculus, equations, that's a basic part of it. We got to get equations down, and we're going to start with the most basic, which is 3-1, solving equations and they put it with addition and subtraction. Okay, and what I want to say to you guys is several of these examples are going to be very easy to do. In fact, some of you may even be able to do them in your head, but I'm going to make this very clear to you right now, at the end of the lesson, and then maybe one other time before you leave. You have to show me your work. You must do it, because it's not much work, but I need to see what's happening to the equation because it's important. And then later on it gets even more critical and more difficult to not show your work. Okay, so let's look at page 144, first lesson of solving linear equations. And we're going to talk about two properties today. The first property, which with an asterisk means it's very important. It's called the addition property of equality. Okay, this chapter, as you guys remember, is called solving linear equations. So we're talking about equations, which means now we're talking about properties of equality. We're going to look at two today. There are more. And these are important because equations are a big part, like I already said before. Okay, can someone read for me on page 144 in that little yellow bar? What is the property, addition property of equality? Go ahead, Josh.
For any numbers a, b, and c, if a equals b and then a and c equals b plus c.
Okay, and if you just if you look through that too quickly, it's like, what are they trying to say? I'm going to summarize it as succinctly as I can. If a equals b, okay? So if you have two quantities that equal one another, then A plus C equals B plus C. That's the addition property of equality. And yes, we're talking that A, B, and C are real numbers. Or any numbers, actually, yeah. This is going to go to imaginary category too, but any numbers. If A equals B, then A plus C equals B plus C. What does that mean? What does that mean? Eli, what does that even mean? Okay, that is actually another property kind of in there. A and B can be swapped and still keep it the same. But what does it mean by A plus C equals B plus C? Like, I get A equals B. I get that. Two things equal each other, but what does the second part mean?
Does it mean both, like integers or whatever?
Or numbers,
equal the same thing?
Okay, there you go. You want to add to that or say something else? Okay, this all it means is with equations, guys, and I did this last year, and I told the other class, you know what? Last year you guys were 7th graders, you were a year younger, and your minds got more rational in that year. Your minds got more critical in how you think. Your minds got more mature overall. So I remember last year I had one of you stand here, one of you stand here, and we had a scale, and I put a book in one hand and a book in the other, and I try to picture it out. And I'm thinking to myself, these guys are 8th graders now. They get it. So now I'll be the scale, right? So you guys know what a scale is? Like those old balanced scales? When you're talking about an equation, if it's a true equation, both sides of the equation have to be, what do you call it when they're evenly distributed? Equal, and there's a special word about, it starts with B. They are balanced, right? They're balanced. They're even, they're equal, balanced. Okay, if I add the same thing to both sides of the scale, when there was that first balance, what happens to that scale? It stays balanced. Okay? That's what the addition property of equality means. If you add the same thing to both sides of an equation, it's still a balanced equation. Okay? The second one is like unto the first. And it also deserves an asterisk. That's a fun word to say. And it is called the subtraction property of equality. Sorry? Asterisk. Yeah, it's one of the hardest words that I have to say out of many. Asterisk. Yeah, I think we sometimes slur the word, and it's like asterisk or asterisk. I'm trying to say it right, and I can't say it wrong anymore. Can anyone give me this property? It's in the next page, 146. Don't look at it. Can anyone kind of give it to me based on the addition property of equality? Beth?
If A equals B.
All right, it starts the same way if A equals B. Same start. You got a balanced equation. Go ahead.
Then A minus C equals B.
There you go. If A equals B. If you have a balanced equation, then A minus C is equal to B minus C. What does that mean? So give it to me with the scales. You got it balanced. How do I practically show that to anyone? Do you remember how I did it with you guys last year? Yeah, what I do instead with giving you a book? I took away the book. Same weight, right? And so what happened to the scales? They remained balanced. Okay, so that's the same property. Now, I want you guys to think here. I'm looking at these two properties. Don't they look really similar?
Yes.
Can I put them into one property?
Yes.
Somebody tell me how I would do that. Okay, go ahead, Benson.
Could you make the two verses together?
So what would you say, like, kind of give me an example. So if A equals B, that's going to be the same.
A equals B, then A plus C or A minus C equals B plus C or...
Yeah, so good. You're kind of putting them together. And that's good. That is how you put them together.
If A equals B, then A plus negative C equals B plus negative C.
Hey, look at this. Look at this right here. A minus C. Everyone's okay with that. We understand that subtraction. Could I have said A plus negative C? Yes. Right? And could I have said B plus negative C here? Yes. I can tie it all to the addition property of equality. Now, I'm going to bring that up again later. So please think of how to look at this right here. This is addition. But can this be written as addition? Yes, it can. And we're going to use it because it is helpful. Okay, we're almost done with the theoretical, the properties and rules, and then we'll actually get into some actual problems. Oh, there you go. Where'd my paper go? Here it is. All right, last part here. Let's look at an equation. And they gave us some cool numbers. They gave us 44. So 44 equals 44. Can someone tell me if that's true or false? Good, because it is true. And actually, I like the way you put it, Benton. You said, I believe it's true. I'm like, interesting choice of words. Huh, interesting. No, and I'm glad you brought it up. I want to bring this up because, listen, guys, we're in a Christian school. So who do we put first in all of our education? God. He has to be first. And he gives us this, but let me tie this in. Ready? Don't get overwhelmed by this. I'm trying to give you what we can't give you in a public school. I can't say this in a public school. I'm done. Like, Swivl sees me, I'm done. You'll never see me again. Never see me again. All right. Do you guys know what the word moral means? You know what it means by moral? Like to be moral. Ethical is a good synonym. Synonym is a good synonym. It just means this, to be able to distinguish between good and evil, right? Good and bad, right or wrong. Okay, let me ask you this question here, guys. Is this moral?
Yes.
I believe so.
Okay, I believe so. I heard yes. Anybody? Just give me your feedback. Is it moral? You're like, what? Good or evil? Like, is this a struggle of good and evil?
I
That's
know
deep.
what you're going to say.
Okay,
It's
so,
good.
okay, it's good. Why?
Because anything else not like reflecting his creation on how he made it would be evil.
Okay, how about this? And I'm not gonna, I don't want to say like too like, wow, this is evil, but I'll tell you like this. This is true, correct? We agree. We're not gonna say it. No one's gonna say, Mr. A, I don't think that's true. I think you have no case to say that. But this is true. Who is the originator of truth? God. If this is really true and that really reflects Him, this is moral. To say this is true, that is moral. This is good. Okay? If I were to say 43 equals 44, some of you would be like, Mr. A, you're going crazy. But guys, I can try to convince you, and there are people who try to convince that fact. But what I'm trying to say is, if this is truth and it reflects Him, then this is moral. I don't want you guys to get too deep into this. I'm not trying to spiritualize it. It already is spiritual. When you give a answer that is true, you have just reflected His character, whether you knew it or not. If you said, I don't care, 44 equals 44. You don't care about truth? That's a moral issue. And I don't want any of us to be guilty of that. And not to get too deep into this, but listen, in our educational system today, because of the influences of the history, years past, hundreds and even thousands of years, we're saying now, this is not good nor evil, it's neutral. And it's not. It is good. And it's also good that you use your grammar and your history and your science. These are good things because they come from God if they're really true. And obviously people can say things are true and not really be true. Yes? I hope you guys agree.
So basically, you know how you said 43 equals 44, I think that's absurd, and that's not the truth. Well, anything that's not the truth is basically that absurd.
Not absurd. I would say like, you guys know 43
Crazy to
equals...
comprehend.
I would say like, it's not true. I'm going to go light. Like, it's just not true. Thank you. That could confuse people. I don't want to say absurd because I remember on IXL when you guys are doing your thing, I was like working it out on my own, and I got it incorrect. I got many, by the way. I was like, oh man, I messed up, and that I needed to correct. I need to find out what's the right answer, how to get it right the next time, because I want to reflect His character. But let's say here we're going to get into this. If I add 5 to both sides, what do I get?
49.
I get 49 equals 49. Now, this statement now, is that true or false? It is still true. When I added the same thing to both sides, did I change the truthfulness of the original equation? And the answer is no, it's still true. Good. I'm glad that happened. Let's take that 44 again. And that is a true statement because we agree with, not because we agree with it, because it is. 44 does equal 44. Nothing you do to change that. Sorry. What if I subtract 3 from both sides? What am I left with?
41.
Good. 41 equals 41. Is that still true?
Yes.
Yeah, I didn't change the truthfulness. That is nice to know. Okay, but the reverse is also true. Let's go back to that 43. Is this true? It is false. But what if I add 10 to both sides? What do I get? Plus 10 and plus 10. What do I get? 53 equals 54. Did I change it from false to true? No, it is still false. So here's the concept in those 3 equations, adding or subtracting. When you add the same thing or subtract the same thing from both sides, do you change its truthfulness? No. It was true at the beginning, it's true at the end. If it was false at the beginning, in this case, it's false at the end. You don't change it. Sorry,
So,
Taylor.
on like future homework,
Yep.
it says like 43 minus 2, and it says not like simplified.
Okay.
We just put 43 minus 2 as the answer.
No, so what it means, when it says solve, it wants you to tell what does the variable equal. So you can only solve if you have an equation and if you have a variable. Like there's nothing to solve here. You're just adding something to both sides. And we'll actually go into what does it mean to solve. Because a lot of my students in 7th grade are like, Mr. A, do you want us to solve this equation? Do you want us to solve this problem? I'm like, there's nothing to solve. You just simplify it. So the terminology means something. But when I get there, Taylor, ask me that question if it's still like not answered, because we are going to get to solving. write this equation down. And this is what we're actually going to be doing in our assignment here. All right, this is a true equation because I marked it as true. And if I figure out what y is, I have solved the equation. But we're not getting to that yet. Can somebody tell me what happens if I add 3 to both sides? What do I get now for my new equation? What do I get with this new equation? James, what would you get if I added 3 to both sides?
3 plus 7 equals 16.
Y plus, you'll get y plus, if you added 3 to both sides, you get y.
10 plus.
I'm going to show something here. Equals 16? No, because you're adding it. If you're multiplying, you would have to do 3y plus 21, the distributive property. Okay, this is the whole point I'm trying to make. These two equations here, okay, the old one and the new one, they are called, and this is the term I want you to get, equivalent equations. What does the word equivalent mean? That's right. Equal. Very good. Very good answer. Equal equations. And I'm like, wait. I'm looking at these two equations right now, guys. Yeah, they both have y, and they both have an equal sign, but they have different numbers. They're not the same. They're not the same equation. They're different. Why do we say that they're equivalent then? Or why do we give it that term, equivalent equations? They have the same this. This is what they have the same. What is it? They have the same, and anyone want to give it? I haven't heard it yet. The same, close. They do have y, but they have the same solution. Same solution. And I'm like, wait. Is it really? Yeah, what's the solution to y up here? What's y equal up here? 6. What's y equal down here? Do they have the same solution? They are equivalent equations. Little did you know, and this is something little did I know before I started teaching, that we've all dealt with equivalent equations since like 2nd grade. We're dealing with equivalent equations all the time. And I'll try to point those out as we go. But here's one example. Yes, sir?
Not a grammar thing. Would it be incorrect to call symmetrical equations? Because symmetrical means like the same.
So symmetrical tends to deal with like reflection. So like if you put y plus 7 equals 7 plus y, that's more symmetrical. That term means symmetrical. So that's why you have that symmetric property. And that's y plus 7 equals 7 plus y. That's symmetry. Reflection of the equivalent means they, in this case, they have the same something, and specifically the solution. And we're going to deal with this the rest of chapter 3. This is chapter 3, equivalent equations. All right, now let's get into example 1. All right, example 1, one of the most basic problems you'll deal with. 23 plus t equals negative 16. All right, man, these allergies are getting to me, guys. Fall is in the air, and I love fall, but I'm getting afflicted by allergies, as I can notice some of you are. Yeah, go ahead. Yep. Swivl, you picked that up. Good, thank you. They have allergies too. Here, the whole goal in this equation, right, equation, is to find what t is. That's solving an equation. When I find what t is, I have solved the equation. Now, I told you what at the beginning of this lesson that you need to do on all your problems. You need to show your work. There is no excuse anymore for showing your work on these, and trust me, it will not be overburdened, okay? Great question. Let's go ahead and do it. All right, this is simple, guys. This is very simple, and we're starting simple. This is 3-1. Once we get to like 3-4 and 5, good luck trying to make it in your head. It's not going to work effectively. Not going to work at all effectively. Look at the variable, and what is going on with the variable? It is being added with 23. Good, or a positive number. What undoes addition? Subtraction. So what would I have to do to both sides to get t by itself? Subtract 23. That's your work. That's your work. And I draw a little line here to distinguish that I'm adding. Oh, I'm using that too early. That I'm subtracting 23 from both sides. Okay, what's 23 minus 23? That's 0, right? And I'm going to write this first time. You don't have to do it later, but I'm going to show you something. So it's 0 plus t equals, what's negative 16 minus 23? Negative 39. Now, I use the subtraction property of equality right here to subtract 23 from both sides. When I put 0 plus t equals t, what property did I use? Additive identity. Isn't any number plus 0 the number? So I just dropped that 0 out. So t equals negative 39. That's your answer, okay? Negative 39. Nothing too hard.
Didn't you do that last year? Where you did the thing? I remember that.
Yep, and good. It's just review. Now you're going to get fractions and decimals and more of them, but you'll be ready.
Yeah, I wish we could stay just with integers.
Exactly. All right, just to make sure you guys are good at this, on page 148, go ahead and just do number 6 and 7. I'm going to ask what you did to both sides and then what you got. I'll ask two of you, one for each. So go ahead and do number 6 and 7 on 148. I need to see work. It's not acceptable without work. In fact, just like I told the other class, we're going to grade your homework tomorrow for the answers. You're going to hopefully get those answers right. And then I'm going to look at them. If I don't see work, I'm going to make you redo the homework in order to get a grade. I need to see the steps. It is easy now, so enjoy it. It will get tougher. Well, it lasts. Yep. Okay, so Benson, on number 6, what did you do to both sides?
I did minus 10 and minus 10.
Okay, so you subtracted 10 from both sides, and what do you get for your answer? What's your solution?
I got m on the left side, and on the right side I got negative 3.
So m equals negative 3. Very good. That's it. That's all you have to do. Show negative 10 on both sides. That's it. All right. On number 7, if you're still working, that's fine. But on number 7, what did you do to solve this equation, Josh?
Yes. I added 15 to both sides.
Okay, added 15 to both sides.
And I got a equals negative 17.
A equals negative 17. All right, how many of you got those two? M equals negative 3, A equals negative 17. Okay, maybe you're still working on it. It's okay. But we had the balanced scales, and we took away the same thing from both sides. It's still balanced. We had balanced scales, and we added something to both sides. Still balanced. Okay, we're not doing anything against those properties that are true. Okay, let's go back to example number 3. And here's a problem. I love these next few problems because they're going to help us with some of the commonly missed problems that we have because these throw us off for some reason. All right, so 190 minus x equals 215. Okay, look at x. What's happening with x? Somebody describe it. And I'm going to hear words. Taylor, what's happening with x?
Being subtracted from
Very good. It's being subtracted from 190, not subtracting 190. And that's important. So what do you think to do? What undoes subtraction? Well, duh, addition. Interesting. All right, I'm going to work this problem out twice. I'm going to work it out the correct way the first time and the incorrect way the second time. Most commonly incorrect. Let me do the wrong way, and then I want you to help me out with the... I'm going to work it out the correct way. Help me out with the wrong way, like what I did wrong. All right, the first thing I do is this. I want to get x by itself, so I'm going to subtract 190 from both sides. Subtract 190 from both sides, okay? What's 190 minus 190? It's 0. And what's 0 minus x? Negative x. Right? 0 minus x is negative x. And then what's 215 minus 190? think it's 25. All right, so is that my answer? Negative x equals 25? I don't want to know what the opposite of x is. I want to know what x is. So what's x equal to? Negative 25. If the opposite of x is positive 25, x is equal to negative 25. That's my answer. Okay, that works. That's it. All right, and then I have to do this because I don't want to throw you off on your notes. You're like, Mr. Ray, I thought you told us to do it like this. No. Common. So I want you to write this common error. And it should technically be common errors. But I'll try to print those out. All right. 190 minus x equals 215. Here's a common error. What's going on with x? It's being subtracted from 190. Great, you got it. So I'm going to add 190. So I add 190. Are you allowed, now answer this wisely, are you allowed, according to the properties, to add 190 to both sides? Yes, you're allowed to add anything to both sides. All right, good, because I want to do that. All right, cancel. Negative x equals, and that's going to be 405. Nice. Where's the error that we make? Benton?
Well, adding 190 to positive 190
80. Is 190 plus 190 cancel itself out? No. Oh man, but I thought you did do the right thing. You did do something to both sides. That's allowed, but you just didn't do the right thing. It doesn't cancel it out. And then here, oh, Mr. Yeah, I'm sorry. No. It's negative 105. Sorry. Of course, that's the answer. No, it's not the answer. Okay, all that work for nothing. So let me ask you this question, as you can kind of see both answers. Is negative 105 the same as negative 25? No. And this is what I do to make sure it's one or the other. 190 minus negative 105 is equal to 215? Well, of course it is, right? Isn't it? Sounds good to me. That's 190 plus 405. Is that going to be 215? Absolutely not. What about negative 25? What's 190 minus negative 25? Well, it's the same thing as 190 plus 25. That equals 215. There's only one answer there, and it's not that one. That's a common, two common errors is right here, and then some people do this. Even if you didn't cancel that, you're like, oh, it's just an x. No, it's a negative x. Don't forget that negative. I'm trying to help you out here because you're going to see more of these. Oh, they're coming back. I'm going to skip example 4. I think that one's pretty basic. Let's go to example 5 for sake of time. Example 5. Oh, my. Fractions. Man. This is wrong. Okay, this is y minus negative 3/7 equals negative 4/7. Okay, great. I think, okay, watch. I'm going to add negative 3/7 to both sides.
No.
I'm allowed to do that. Am I allowed to do it? Add
no.
negative 3/7 to both sides. I'm allowed to do it. But that gets confusing. Adding, so this is what I'm trying to say. You're going to do this. It's possible. You can do that. It's allowed. Properties are good. But I'm not going to do that. That's confusing. You know what I am going to do? Make this equation simpler. How can I rewrite this to make it simpler? Because right now, negative minus negative. Wait, which one is it? Let's change it.
Y plus 3/7.
Y plus 3/7 equals negative 4/7. Oh, thank you, Judge. Oh, that's so much easier to deal with. Okay, you know what process we use? Here it goes. Here's the bonus. Here's something I'm giving to you. You have all rights to use it. Ready? It's a process of stay, change, opposite. Oh, opposite. Copyright. You can use it with permission. Okay, what just happened here? Ready? If you want to change a subtraction problem into an addition problem, this is what you do. Did I keep the first number the same?
Yeah.
Stay.
Yeah.
Did I change the operation?
Yes.
Did I get the opposite of the second number?
Absolutely.
Then you can do it. And I made an addition, and now I can deal with it. So what do I do to both sides here? By the way, this is, patent pending if it was a device. But anyway, what do you do to both sides? Say that again. That's okay. Subtract 3/7. There you go. Subtract 3/7. That's hard, yeah. And what's 3/7 minus 3/7? 0. Like it. What's y plus 0? It's just y. And now what's negative 4/7 minus 3/7? Negative 7/7, which is equal to negative 1. That's your answer. It is. Especially with those fractions. Yeah.
Do we have to put the y plus 0 for like in high school?
No, I didn't put y plus 0 either. That was just to help you to see that identity property. But yeah, just y equals whatever the number is. All right, last one here. Last one. We almost made it through. Example 6. Thank you for your attention, and I know a lot of you are very comfortable with this, and that's great. I'm glad. Example 6 is b plus negative 7.2 equals negative 12.5. All right, so tell me what to do on this one. Oh, I already know, guys. Subtract negative 7.2. I know, man. I wish there was a 3-step process to change this to a different operation. There's only one out there. Oh, someone did come up with it. I did not come up with it, but I did come up with that, and I will keep that now. Right, Swivl? So America and any other country, please realize that this has been copyrighted in the presence of many witnesses, and it's half the proceeds will be dedicated in memory of you guys. So when I buy that PlayStation 6, every time I turn it on, I'll think of you guys. Okay, anyway. How do I change this to make it look a little bit better? Because right now, this is kind of confusing. Why don't I change it to this? Ready? Stay, change, opposite. Doesn't it make it just easier to look at? And if it's easier to look at, usually it's easier to deal with. So I add 7.2 to both sides. And those would cancel each other out. And I'm left with b equals, and then what's negative 12.5 plus 7.2? It's a subtraction problem. You have opposites being added. So you're going to get negative 5.3. Negative 5.3, okay? You see how that works, guys? I'm trying to help you out. Listen, I know I talk a lot. Trust me. It's a character flaw. And I'm trying to condense my words, but I do also want to know the things I tell you up here, it's just to help you out as much as I can. I won't always have you in my class and give it to you as much as I can. That's my goal. All right. Your homework tonight. Any questions on this stuff? Please show me your work. That is a great question. Bye, Swivl.